Welcome. So in this video, we're going to be talking about graphs of factorized cubic functions. So this is a factorized cubic, and we're going to be learning how to sketch it. Now, previously, we have sketched cubics, but cubics in this form right here. And when they're in this form, we know they look like this. So this is the graph of a cubic in this form. And we had a point of inflection here. So this flat point right here was our point of inflection. So that's what we've previously seen, but this isn't the only way a cubic can look like. A cubic can take a different shape. So let's learn about a different shape it can take. So we're going to be sketching this before us. So it says roughly sketch each of the following, labeling only x-intercepts. So we can find the x-intercepts of this pretty easily. We know how to do this. We're just going to solve it, which means we're going to use our null factor theorem. So we're going to take this x minus 1, and we're going to set it equal to 0. We're going to take this x plus 4, and we're going to set it equal to 0. We're going to take this x plus 2, and we're going to set it equal to 0, which means I'm going to get x is equal to 1, x is equal to negative 4, and x is equal to negative 2. So my x-intercepts are going to be 1, negative 4, and negative 2. I can now put those points on. So I'm going to have 1 here at negative 4, 1 at negative 2, and then 1 here at 1. Now I need to draw a line through these points. Now, hopefully you can see something here. I could draw it like this, up, then down, then up. But there's also another way I could draw it. I could draw it like this, down, then up, then down. So which way do I draw it? Do I go up, then down, then up? Or down, then up, then down? How do I figure out which way to do it? Well, the way to figure out how to do it is by considering the following. If I was to expand this out, would I end up with, if I was to expand it out, would I end up with a plus or minus x cubed at the start of it? And hopefully you can see that it's quite clearly, for this example right here, I'm going to end up with a plus x cubed in front. And I can tell that because I have an x, a positive x, a positive x, and a positive x. So when I multiply all those together, it'll be positive x cubed. So just to kind of reiterate that point, if I was to come to my cas here, and I've simply put in what I have here, and I'm going to expand it, you can see I end up with a positive x cubed here, a positive x cubed. And what that tells me, when I have a positive x cubed, is that when I come to draw this now, what it's going to look like is this. I go up, then down, then up. That's what I'm going to do. So when I have, let me repeat this, a positive in front of my x cubed, I go up, then down, then up, not the other way. And let's just quickly put in my x-intercepts here. So this is going to be negative 4, 0. This one here is going to be negative 2, 0. This one here is going to be 1, 0. Perfect. Now, the next thing that we have to consider is the turning points. So do I have to label the coordinates of the turning points? And you don't. So let me just quickly write that in. Do not determine the coordinates of the turning points. So do not determine turning points, TP, coordinates. We do not want you to do that. Now I always struggle with spelling coordinates. Coordinates. We do not expect you to do that. Without using your cas, you can't find the turning point coordinates. Later on in this unit, we'll talk about calculus, or another unit rather. We'll talk about calculus, and with calculus, you actually can find the turning points. But for now, just worry about drawing a nice, smooth graph. Don't worry about finding the turning points. So again, do not determine turning point coordinates. What you have to worry about is finding your x-intercepts and determining whether or not you're going to go up, then down, then up, or the other way. Okay, let's now move on to our next example here. So in our next example, we can quickly just find out what our x-intercepts are going to be. So we know that if I was to set this equal to 0, it's just going to be x is equal to 0, so we've got 0 there. This would be 1, and this would be 3. We also know that if we were to expand this out, I'm going to end up with a positive x cubed. Again, the reason why I know that, I don't have to actually expand it to figure this out. I know that I have a positive x, and a positive x. So if I was to expand that out, I'm going to get a positive x cubed. So now what I'm going to do is simply put in where my x-intercepts are there, one here and one there. Because it is, let me repeat this, because I have a positive here, that means I go up, then down, then up. And let's see if I can draw that a bit nicer, shall we? It's going to go up, then down, then up. So it's going to look something like that. Hopefully yours looks a bit nicer. Let me come here. So this is going to be 0, 0. This one here is going to be 1, 0. And then this one here is going to be 3, 0. Again, let me repeat. Do not determine the turning point coordinates. So a cubic, unlike a quadratic, the turning point is not going to be symmetrical in terms of, it's not going to be exactly in between the x-intercepts. That's not how a cubic works. So you just can't figure it out without the CAS or without calculus. So do not worry about the turning point coordinates. Just draw a nice graph and you'll be fine. Okay, we keep on going to this one now. So how are we going to do this? Well, first things first, let's figure out what our x-intercepts are going to be. It's going to be 1, it's going to be -4, and it's going to be -2. So I can come here and I can put those in. I got -4, I've got -2, and I've got 1. And now we have to consider something. Do you see how I've got a negative here? The fact that I have a negative here tells me that if I was to expand this out, I would end up with -x cubed, and then ... something. That is, I know that is true. This negative is going to cause a reflection. So that means when I come to draw this now, unlike my previous two examples where I went up, then down, then up, I'm going to go down, then up, then down. My graph is going to look like this because it's reflected, because I have this -x cubed. If I was to expand it. So let's quickly label this -4, 0, -2, 0, and 1, 0. Just to kind of reiterate this, and because it is an important point, if I was just to come down here, and here is this graph here. So if it's positive, it looks like this. So as you can see, I've got the points -4, -2, and 1. Now, if I was to make it negative, I end up with that. Positive, negative. So it's going down, then up, then down. Or if it's positive, it goes up, then down, then up. Let me just quickly take a drink of water. There we go. I've got a terrible tickle in my throat. Okay, so that's how you do it. So if it's a negative, it goes down, then up, then down. If it's a positive, it goes up, then down, then up. But the x-intercepts stay the same. All right, so we got that. Perfect. Let's move on to the very last one here. So we're going to figure out what our x-intercepts are going to be. For this one right here, it will be a half. For this one here, let's not get stuck. It's going to be 2 minus x equals 0, which will be -x is equal to -2, which means x is going to be equal to 2. And then this one will be -3. Okay, now that I've done that, we could put those in. So I've got -3, I've got a half, and I've got 2. All right, now I need to figure out whether or not this is reflected or not. Now this is one you have to be careful with. Do you see how I have positive x, I have a negative x, and then I have a positive x? Well, the fact that I have a negative x tells me that if I was to expand this, I would end up with -x cubed, ... something. So let me bring up my CAS to kind of show you this. So let me just quickly bring this up for a second. Let me just move this to the side a bit. So if I was to expand this out, I'm actually going to end up with a -x cubed. So calculus, sorry, algebra, expand. It's going to be 2x minus 1, 2 minus x, x plus 3. 2x minus 1, 2x. Do you see how I get -2x cubed? A negative in front of it. So don't worry too much about this too. I'm really concerned about this negative in front of it. The fact that I get a -x cubed tells me that this is going to be reflected. So the fact that I have this right here tells me that I'm going to get a reflection. So now when I come to draw this thing, we have to be careful. It's going to look like this. It's going to go down, down, then up. Oh, that's terrible. down, then up, then down. That's actually pretty good. So be really mindful if you're going up, then up, or down, then up, then down. And now if I was to put in these points, this is going to be -3, 0. This is going to be a half, 0. And this will be 2, 0. Perfect. So we really need to take note of whether or not we're reflected of our X-intercepts. And then really importantly, don't worry about finding the turning points. You just can't do it without your CAS yet. The final thing I'll say before I end part 1 is that in the textbook, it makes mention of something called a sign diagram. Is to figure out whether or not you're above or below the X-intercept. Do not worry about them. We're not going to test you on them when we don't expect you to do them. So in your exercises, just ignore the sign diagram. If you use the technique that we're showing you here, you'll be able to do all the questions fine. Hopefully you enjoyed part 1, and I'll see you in part 2 real soon.